Hello friends, welcome to the next chapter. Over here, we are going to understand the concept of pumping lemma. Honestly speaking, this is not a chapter, this is a subtopic itself, an important short note which is asked in the exam. So now, pumping lemma for regular language. First of all, we know what is a regular language, right? So we also know why is a regular language insufficient for not solving some of the problems. That is the reason we moved from finite state machine or finite automata to push down automatas and further to Turing machine. So now pumping lemma is basically a kind of theory to prove that a language is not regular. Now let us understand, what do you understand from this? Let us say you have a problem for solving a raised to n, b raised to n, okay, where I have given n's value is going to be between 0 to 4. And if I say please design a finite automata for the same, so you may say, you may have a state like q0, on getting a goes to q1, on getting one more a goes to q2, on getting one more a goes to q3, and this on getting a b comes over here, on getting a b over here, on getting a b over here. So over here we see that 3 number of a's and 3 number of b's can satisfy. So let us add one more q4 over here, where on getting a it comes over here, on a b it comes over here. So now friends, when we start from q0, we see that if I have n's value is equal to, let's not consider 0, consider 1. So n's value would be 1, so that would generate the string AB, and is AB accepted? Q0 goes to Q1 on A, Q1 on B comes to Q0, and we go to the final state. That's accepted. If we consider n's value as 2, the string is AA, and that also is accepted by going from Q0 to Q1, Q1 to Q2, Q2 to Q1, Q1 back to Q0. Similarly, n is equal to 3, that is 3a's and 3b's are also accepted. N is equal to 4, that is 4a's and 4b's are also accepted, right? What if I say it has to be not for n 0 to 4 or n 1 to 4, but it has to be for n greater than equal to 1. So if this is the language, everyone might be coming on with the solution that let us keep on pushing the remaining a's over here and pushing the remaining b's over here, and this is going to satisfy. You can check. Let us assume we have 6 a's, so we will be having 6 b's. So of this 6 a's, 4 a's would be utilized for going from q0 to q4, and the remaining a's would be in the cycle of q4 itself. So 2 of the a's would be in q4 itself. Further, this 4 b's would be utilized in coming back to q0, and 2 of the b's will be utilized in q0 cycle itself, and this machine is accepting for n greater than equal to 1. But friends, what if I have an input like a just followed by 4 b's, or maybe more number of a's and followed by this? So now over here, first and foremost thing, this particular thing is not of the form a raised to n, b raised to n, because the number of n's of a are greater than number of n's in b. So this should not be accepted by the machine which we have designed. Let's see whether this machine does not accept it. So for this first 4 a's, I go from q0 to q4. For the remaining 3 a's, my q4 is going to run in a cycle and take all these a's. Then for the 4 b's, my q4 comes back to q0 and it is accepting this input, which ideally it should not. So we have found a drawback over here, that my regular language cannot be designed using the finite automata. So for such type of language or such type of problems which are not capable of being designed using finite automata, we have to go for the next machine which we have already studied, called as push down automata. So friends, as I told you earlier, pumping lemma is basically a kind of theory which is going to prove that a language is not regular, therefore it cannot be designed using finite automata. So that is what we are going to study over here. So let's understand some theoretical aspects of pumping lemma. The concept is actually very simple. Honestly speaking, if you keep your head a bit aside and understand it, because if you try to get into the deeper mathematics of it, you are going to waste a lot of time and energy over here. We have to be practical. It is simply going to be a 5-mark short note in the exam. What is important, I'll be focusing over here, and that itself has to be written in the exam. That would definitely suffice to your needs. So let's get started with the theory. Now, how do you define a pumping lemma? I say let L be a regular language, then there is going to be a number called as P, which is called as pumping length. Now, pumping length is going to be the cycle which we discussed over Q4 and Q0. So I'm going to keep on pumping more number of inputs in that particular state. So let L be a regular language, then there is a number P, that is pumping length, where if W is any string in that particular language of length at least equal to the pumping length, then W can be divided into 3 parts. W is equal to X, Y, Z, and these 3 parts have to compulsorily satisfy the below 3 conditions. What are the conditions? For each I greater than equal to 0, my X, Y raised to I, Z belongs to the language. Second, my Y cannot be equal to epsilon, so pumping length has to consist of some input. It cannot be equal to empty string. Lastly, mod of XY has to be less than equal to the pumping length. So friends, that's how we define pumping lemma. Now I am very sure everyone might be a bit confused as to what is going on. Till now we were understanding everything and now the things are going haywire. Don't worry. As we solve the problem, each and everything of this is going to become clear. As I told you, please don't get into the deeper mathematics of it. What you need to understand is the approach to solve the problem, and that is my duty and I'll satisfy it. Going ahead, next is the definition of pumping length. Pumping length is a finite value so that P has a cycle. As I told you, we are going to push some of the inputs. P must be equal to or greater than the number of the states in the deterministic finite automata. So friends, this is important considering the theory for pumping lemma and what is the definition of pumping length. Now, having understood what it is, at least a glance of it, at least looking at it, what is pumping lemma. Now in the next video we are going to solve problems on it which will make each and every line and word of the definition crystal clear to you. So with this, we stop with this video. See you in the next session solving the problems on pumping lemma. See you. Thank you.